They look at stationary point, which are also called turning points, and their nature. All right, what I mean by that? Suppose you have a graph looking like this. Right at the top of this hill is a stationary point or a turning point. It means if you should walk along the hill, then you are going up and up and up and up and up. So, in other words, you're going from left to right, and you're rising, meaning that the hill has a positive gradient. Then after you pass the top of the hill, you start going down and down. Now, that means the hill would have a negative gradient. You've turned from the gradient from positive to negative right at the top of the hill, and at that point you turn from positive to negative. So you're at a turning point. You're looking at a turning point where you turn from positive to negative, right? So this is a maximum point. That's the nature of this point. It's maximum. And it's stationary, as we have looked at in previous videos. The gradient is 0. Alright? So you have a stationary point there. You can imagine that if you put a ball on this tangent, it would roll down the hill. You put a ball on this tangent, it would roll down this hill. But if you put a ball on this tangent, it would stay where it is, stationary. Unless you have breeze blow on it or somebody moves it, it will be stationary, right? But the nature of this point is it's a maximum point. If, well, by the way, a graph such as negative x squared plus 2x minus 3 gives this type of curve. Here, a graph such as x squared plus 2x minus 3 would give this type of curve. And you have a minimum point. That's the nature of this stationary point. The stationary point would be right at the bottom of the valley, and the gradient would be 0, right? It's also a turning point, because if you want to move from left to right, you'd have to climb down this hill. And you're going down and down, meaning you have a negative gradient. So the gradient is negative on the left of that point. Then when you reach over here, you'd have to be climbing up the hill. So the gradient is positive. You draw a tangent and it has a positive gradient, meaning that you have turned from negative to positive, and it is at that point that it had turned. So this is a turning point, and the nature of this point is minimum. So when you're going from left to right, if you change from positive to negative, then you have a maximum point. If you turn from negative to positive, then you have a minimum point. Now, here, let's look back at this graph. Let me redraw it. If you have a graph looking like this, right here is a turning point. If you calculate the value of a point on the left and the right, and they are lower than that of the turning point, these are the values here, and the turning point is up here, then you see it's a maximum point, right? If you have a graph like this, so basically what I'm saying, this is x and y. This is y1, this is y2, and this is, call it yp. y1 is lower than yp. You can see it. y2 is lower than yp. And if the turning point is at x equal, say, xp, this would be x1, this would be x2, x1 and x2 correspond, x1 and y1 correspond, x2 and y2 correspond. When you calculate the value of the point at x1, you get y1. When you calculate the value at x2, you get y2. But the value of xp is yp. Suppose yp is, say, 15. On the left of yp, your xp is this value, and you calculate yp is 15. On the left of xp is x1, and you calculate the value of y there, and it is right here is 14. Let me just not put the 14 up there. Let's say you calculate y1 for x1 and you get 14, and you calculate y2 at x2 and you get 14 too. It means going from y1 to y2, you rose and then you fall, and you see that a maximum point is there. Alright? You can also calculate the gradient of the curve at y1, and that would be a tangent. The gradient is positive. The gradient of the curve at y2, the gradient is negative. So you see you have a maximum point there. Alright? Now the gradient at yp would of course be 0. So on the left is positive, on the right is negative. It means you're going up, then you get flat and then go down. So it's a maximum point there. Alright, so the nature of this point is maximum. If you have another graph, and that graph is like this, you probably have not plotted the graph before to see what's going on. So let's say you have your value at x at the point, and you calculate yp. Good. And let's say yp is equal to 15. Then you calculate for x1, you get y1, and y1 is 16. And you come over here and you calculate the value close to xp, call it x2, and what you calculate is y2, and you get 16. Those two values are higher than yp. So it means it looks as if you're having a minimum point there. Alright? What you have is a minimum point. Also, if you calculate the gradient of the graph, and you find that the gradient of a tangent to the graph on the left is negative, and the left of yp is negative, and on the right of yp it is positive, then it would seem as if you have a minimum point. Alright? Seem as if you have a minimum point. So let's look at it again. Let's look at this thing again. These dots keep jumping on the screen. You have a certain function, an equation, and when you differentiate it and equate it to 0, you see that it has a stationary point The stationary point is at x s, which is a turning point. Sx is your stationary point, and the value of y is ys, stationary. Now you calculate the value at ys. Then you will choose a point to the left of xs. Let's call it xl, and you calculate the y for it. What you have in that case is yl, y left, and you calculate that value and it is lower than ys. Then you go to the right of xs and choose a point xr, x right, and you calculate the value of y for xr and you get yr, and yr is lower. It means if you should plot the points, and you get this point for ys, y at the stationary point, you get this point to the left. This is the value of y on the left and the value of y on the right. What you would do when you're plotting the graph is something like this, and you see it looks like a maximum point. Alright, that would be a maximum point. Now here, that is one way of finding out the nature of this point. Now the thing is, another way to find out the nature of that point would be to calculate the gradient on the left and the gradient on the right of that stationary point. If you have a positive gradient on the right, on the left, and a negative gradient on the right, then what you would have is a maximum point. I just shorten my POSITIVE with a plus VE, and my NEGATIVE with a minus VE. Less writing, save energy and save ink. Alright. Now, if you choose you find out that your stationary point is at xs, x stationary, and you calculate the value, the corresponding value is ys, which is y stationary. And you choose a point to the left, x left, of the stationary point, and you calculate the value of y for it, and this is y left, and it's higher than y stationary, and you choose a point to the right and you say this is x right, and you calculate the value of y for that value of x, and you find out that it is y to the right, and it is higher than what you had at the stationary point. Then what you would get is a minimum point. Alright, that would be a minimum point. Now let's look a little more at this type of situation in a different video, so I will see you there.